All right, let's get started. So, hello everyone, good afternoon, good evening, wherever you are, greetings and salutations. My name is Christopher Black. I'm a solutions engineer with CircleCI, and in today's webinar, we're going to be talking about deployments. Specifically, we're going to be talking about building, testing, and deploying Docker images to some kind of container orchestration service, be it ECS or Google Compute Engine. But before I kick things off, I just want to let everybody know that we're going to be doing live Q&A towards the second half of the presentation. And I've got a couple of my colleagues who are going to be helping field with questions as well. So two people on the solutions engineering team, George Reyes and Eddie Webb, are also going to be helping take questions, as well as Matt Petrowski. So without further ado, let's dive right in. Before I get started, we've got a couple of live deployments. We're going to talk about building, testing, and deploying Docker images. We're going to talk about a couple of key product features. Let's just talk about where we are and how we got here. So CircleCI was founded in 2011 with a simple premise: to help software teams of all shapes and sizes, from two guys in a pizza.com to some of the world's leading firms, build better software quicker and more reliably, right? And in many respects, that's kind of the crux of the DevOps movement. And just, a little bit about my background. When I first started CircleCI 3 years ago, I was a site reliability engineer. My background is very much ops, back-end, infrastructure kind of stuff. And when I first started CircleCI, there wasn't CircleCI 1.0 or CircleCI 2.0. It was just CircleCI. And it was a monolithic application. But, the first... I want to say the first mainstream, cloud-native CI/CD platform that had a first-class, beautiful integration with GitHub. And, in the past couple of years since I've been with CircleCI, we've completely re-architected the platform. We took the monolith and we broke it up into a series of containerized microservices. We released a couple of really key product features that we're going to talk about today that ultimately lend themselves to deploying software. Workflows, FirstClass Docker support, context, things of that nature. But since I've been here, I want to say I was employee 30-something. We're now at about 160 employees. I might get yelled at the end of the webinar just in case that number has changed a little bit, but we currently have 300,000 plus developers using CircleCI, and that number is quickly growing. And again, just want to talk about how we re-architected the platform in 2017 when we released CircleCI 2.0. So in conjunction with breaking the monolith up into a series of services, we also re-architected our execution engine, right? So in 2011, LXC was our primary container driver, right? This is in kind of a pre-Docker world. Docker's crazy proliferation didn't really start to take off until 2014, 2015, and that obviously had a fundamental impact on the way people build, test, and deploy software. But in CircleCI 1.0, we had a monolithic build image. You could run your build in any image you wanted, as long as it was either based in trusty Ubuntu 1404 or precise 1204. Kind of like Henry Ford when he said you can have a Model T of any color you want as long as it's black. And so we re-architected the platform. We released a number of key product features, and I'm going to dive into those in a moment. But a little bit about my role now. So I started, very much in the ops infrastructure side of things, and then I transitioned into a more customer-facing role about a year ago, and I absolutely love it. So I do a lot of, product demos. I speak to a lot of customers. I go to conferences, and it's really wonderful. And I get to leverage my, extensive ops/infrastructure background in the process. And yeah. So today's topics, we're going to talk about deployment. We're going to talk about deployment in general, but the focus ultimately is going to be on building, testing, and deploying Docker images to some kind of container orchestration service. And we're going to talk about using workflows as a critical part of our deployment process. We're going to go over a couple of sample configs. We're going to do a couple of live deployments throughout the course of the webinar. I think I'm going to cover deploying via SSH. It's a pretty simplistic paradigm, but it's definitely worth covering. We're going to deploy a simple Dockerized Go application to GCP. And then the final deployment is going to be a little bit more robust. We're going to deploy a containerized application that's comprised of two services to ECS. And we're going to do it all live. We're going to do it real time. And then we're going to turn over the second half or so of the webinar to live Q&A. So let's dive right in. So deployments. What is continuous deployment, right? So let's just operationalize these three terms here. I assume we're all familiar with what continuous integration is, right? Where, every time a developer commits small pieces of code, we kick off a build, we run some tests, we validate our assumptions, we get feedback, we continue to iterate. We're all generally pretty familiar with this concept. Where things get a little bit more, I think, interesting is when we talk about continuous delivery and continuous deployment. And again, coming from an ops background, I'm very much interested in continuous delivery and continuous deployment. When I was putting some of these slides together, it's fascinating how many different opinions and different interpretations of what continuous delivery versus continuous deployment means. It's kind of like DevOps. Everybody has their own unique interpretation of what some of these concepts are, and that's totally fine. But these three terms I have here most closely resonate with me and most closely resonate with how I practice DevOps. So we're familiar with what continuous integration is. Continuous delivery, a logical improvement, if you will, over continuous integration. Now we're delivering small modular pieces of functionality in a quick, iterative manner, but the deployment of an application or an asset either to production or to staging or to dev or to a production-like environment is still somewhat manual. Even if the scripts or the logic itself is scripted, those scripts are often triggered manually. Continuous deployment is the full automation of both continuous integration and continuous delivery, right? So I'm deploying, I'm building an asset, I'm running some tests on this asset. I'm taking this asset, whatever it is, it could be a jar file, it could be a WAR file, it could be an NPM module, whatever that thing is. It could be a Docker image in this case, and we're taking that thing and we're deploying it to another environment, wherever that environment is. Again, staging, dev, QA, doesn't matter. And it's really important to kind of conceptualize that we're talking about the entire process automated from commit to deploy. And I want to pause here. I think it's worth checking out Jez Humble and Martin Fowler's book. I think they wrote it in 2007 called Continuous Delivery. It's an incredible read, and it laid the groundwork for a lot of just the terminology that we all use today. And it's really influential. I think the founders of CircleCI read it, were very much influenced by it. It's an absolutely incredible read. And a long story short, Martin Fowler, Jez Humble were some of the first people, thought leaders in the space, to kind of articulate, the automated deployment pipeline, right? And anyway, so these three terms, these are going to be our kind of operationalized definitions for the rest of the webinar. So again, I keep talking about CircleCI 2.0. I keep talking about how we re-architected the platform. CircleCI 2.0 is a significant architectural step forward in terms of just functionality from a user's perspective. But when I was running through this webinar with one of the product managers here at CircleCI, he pointed out it's very important to realize that not only did we re-architect the platform from just like a user's perspective, it completely changed the way we at CircleCI build, test, and deploy software. We use a combination of Kubernetes and Nomad for our 2.0 build system. We re-architected the execution engine. We fully dialed in traffic and usage-based auto-scaling on AWS. So it really changed the way we approach software delivery here at CircleCI. A key feature on our 2.0 build system is FirstClass Docker support. What's FirstClass Docker support? What does that even mean? So again, Docker kind of changed. I mean, Docker, I'm not going to drone on about Docker, but it changed the way we build, test, and deploy software. So in CircleCI 2.0, we have FirstClass Docker support, which means that not only is Docker one of your primary execution environments, that is to say, when you check out code, you run a series of arbitrary commands against that code. Almost invariably, you're either running it in a Docker image or something called a machine executor. But for our purposes, you're going to run your code, you're going to run your build inside of a container, which is really powerful, right? Because if you can containerize your development environment, you can cut down on, downloading any superfluous tools or any superfluous, command line tools, what have you. It's a really powerful recipe. And in conjunction with that, we can also build Docker images at the end of a workflow, at the end of a build, at the end of a job. When we take that Docker image, we throw it in a registry, be it Quay, ECR, GCR, Docker Hub, and then we take that image and we deploy it to some kind of orchestration service. Also, I just want to point out here that on our 2.0 platform, you can run any image from any registry. And this is really important to realize because, we at CircleCI, we maintain a number of what we call convenience images, which are basically community images like, Python 3.3, Ruby, whatever. And then we package a bunch of really popular tools and frameworks and things that are recurrent in the development process into these images. We call them convenience images, but you are not by any means forced to use our convenience images. In fact, if you like some of our convenience images and you want to add some of your own tooling in there, totally possible. As long as you have the appropriate credentials, either stored as a context, and we'll talk about context in a moment, or is just plain old envars, you can Docker pull any image from any registry. And we also see here advanced image caching. So in CircleCI 2.0, we have Docker layer caching as a first-class feature, right? And I think a lot of people get confused sometimes with Docker layer caching versus caching their primary build image. What do I mean? Docker layer caching on our 2.0 platform is only really applicable to the building of Docker images. And that's because all of your Docker commands, i.e. Docker build, actually run in a separate environment. They run in GCP. 95% of our infrastructure runs in AWS. The remaining 5% or so runs in GCP. And because of our auto-scaling cadence on AWS, that is to say the builder boxes themselves, we're constantly spinning up images. We're constantly tearing down images. So it's really impossible, for the aforementioned reasons, to cache your primary execution environment, right? The first image you specify in your configuration file, that's your primary execution environment. We don't cache those. We try to cache those, but we can't guarantee the cache will persist across, various builds. Workflows, okay. I assume that most of you on the webinar have used CircleCI in some capacity. You're probably leveraging some of these features like workflows, like first-class Docker support, maybe even context, which is awesome. I'm just going to pause and disambiguate for a second. So a workflow effectively is an orchestration of multiple jobs, of multiple builds, connected together in some kind of logical fashion, right? So we can run these jobs sequentially, we can run them in parallel, we can fan in, we can fan out, and workflows is vital as we talk about deployments, right? So in our 1.0 build system, we didn't have workflows. All of the logic, the building, the compilation of assets, the testing, the linting, the subsequent deployment, all of that logic was encapsulated in a single build declaration, in a single configuration file. And, make no mistake, it worked. It worked well for a lot of other people. It worked well for a lot of people, but workflows, I think also known as pipelines in Jenkins parlance, really enables you to encapsulate the different, the different logic, the build logic, the test logic, the deploy logic, the linting logic into separate job declarations. And this is immensely powerful for obvious reasons. And a couple other things that come to mind when I talk about workflows, especially in the context of deployments, are branch level filtering, right? So we only want to run a particular job on a particular branch. Maybe we only want to run a particular job on a particular Git tag if we're being fancy. And last but not least, manual approval, right? Excuse me. So in the classic example, we've got a build, test, and deploy workflow. Well, maybe we only want to run that deploy job after somebody clicks approve in the console. Why? Well, you find that even in really sophisticated, mature organizations with really powerful, automated deployment pipelines, they still want a project lead or a team lead or an engineering manager to ultimately click in the console and say deploy before moving any asset into production, before moving it into staging, etc. Okay, context. What are contexts? Contexts effectively are groupings of environmental variables set and administered at the organizational level. I just want to pause for a second. I'm sure many of you are aware that we mirror the permissions model of your VCS provider, right? So be it GitHub, be it Bitbucket. An admin in GitHub in your GitHub org is an admin on CircleCI. A user in your GitHub org is a user on CircleCI. So GitHub/Bitbucket administrators are able to create context and set the environmental variables therein. And it's just a more pragmatic way of dealing with envars, of dealing with secrets. And the classic example I always use when talking about context are AWS deployment keys, right? So you've got like the secret key, and then you've got the super duper secret access key. The credentials come in pairs. That's a really good example of a context. And again, back to the build, test, and deploy. example, we're only going to furnish those credentials on the third and final job in that workflow, the deploy job, right? Because it doesn't make sense to populate those nvars into the build job. It doesn't make sense to populate those nvars into the test job. We're only going to populate those credentials into the deployment job, right? Again, just more pragmatic, separation of concerns, definitely lends itself to operational security, etc. So, quick recap, these are today's deployment targets. I don't have a sample build that we're going to deploy via SSH. I'm going to go through the configuration file just for the sake of completeness. What we are going to do on the webinar, though, is we're going to deploy a simple containerized web server written in Go to GCP using workflows. And the Go project we're going to deploy, it's actually a personal project of mine. It's an HTTP client-side testing service. There's a really fantastic tool on the web I discovered called HTTP bin. It was written in Python and Flask. It's a really, really awesome tool. And, when I was picking up Go about a year and a half ago, I said, I'm going to try to rewrite HTTP bin in Go. I'm going to call it something clever like HTTP Go. It's all Dockerized. We're going to deploy that to GCP. Last but not least, we have a slightly more complex single-page application comprised of 2 containerized services leveraging Docker Compose. And we're going to deploy that to an ECS cluster live on the webinar. And we're going to leverage workflows. And we're also going to talk about encapsulating your deployment logic in a shell script, right? Because most of your, invariably, your builds are running in some flavor of Linux, right? Even if it's the machine executor, you're utilizing the Docker executor, right? At the end of the day, you're ultimately running in some flavor of Linux. And a really powerful methodology, tool paradigm on CircleCI is in your configuration file, just calling simple shell scripts. In fact, in my GCP example, I have a make file. So putting all these things together, shell scripts, make files, and calling those different targets pragmatically in your configuration file can make for really, really powerful recipes. If we were to deploy via SSH, again, this is a bare bones configuration file. This is what it would look like. I hope all of you can see my mouse. I'm just going to assume you can't, so I'm going to just talk through it. But this is basically what the configuration file would look if we're deploying a very simple asset via SSH, right? We've got our workflows declaration at the bottom. We've got 2 jobs, a build job, that's where all of our build logic is going to be encapsulated, and then a deploy job, right? And the deploy job is kind of the, meat and potatoes, if you will. We add an SSH key. We can add any number of SSH keys in the UI. We also have an API endpoint for adding SSH keys. And in order to inject that SSH key pair into your build during runtime, we have to reference said key in your configuration file. So you'll notice right under the deploy job declaration, after we specify the machine executor, under steps, we say add SSH key, and then we just reference the fingerprint there. And then lastly, we've got a single command, deploy via SSH. We see the SSH command, and then it's important to realize you don't necessarily have to, but here I'm using both the username and the host name. I'm setting those both as nvars. And last but not least, you'll notice our workflow declaration down at the bottom. Notice how we have a filter in place. So we're only going to run this deploy job. If we were to deploy via SSH, we're only going to run this job on a successful push to master, right? And we could also include a number of other feature branches. Again, if we wanted to get fancy, we could include some kind of a tag. But in this paradigm, we're only going to deploy via SSH on a successful push to master. All right, let's turn things up a little bit. So if I were to deploy to GCP, in fact, I'll do so in a minute, this is a sample bare bones configuration of what that would look like. I've omitted the build job declaration. I could pull that up in a moment in a text editor, but it's really just running some Go tests and then calling a makefile target to build a Go binary, and we're going to toss that Go binary inside of a Docker image. The interesting thing here to note, though, in our deploy job is that I'm running my build inside of Google, one of Google's convenience images, pre-populated with the Cloud SDK. And then you'll notice all of these run commands here, right? This is how I authenticate my credentials to G Cloud. I'm storing my credentials as a JSON file. And in fact, when I first started experimenting with GCP, I thought this was a pretty clever thing. Instead of the two key pairs that you have with AWS, when you create a service, I was going to say machine user. Google Cloud, they call it a service user. But when you create a service user, a service account on Google Cloud, you get a JSON file that not only has the credentials, but it also includes the private key and a couple other pieces of meta information that I think are really handy. So I authenticate with gcloud. I set a couple of environmental variables like my project ID, which compute zones are GCP's equivalent of regions, and I activate this service account on this Docker image. And then because I built a Docker image in my deploy job, I also have to configure the Docker client because I'm going to push this Docker image. I'm going to push it to GCR, that stands for Google's Container Registry. And I hope all of you can see this. You'll notice Docker push, the image tag. I'm actually leveraging a piece of build-related information, the CircleCI. So if you take a look at our documentation, we actually furnish a number of build-related pieces of information in the form of environmental variables like SHA, like build number, the username of the person who triggered the commit, things like that. So I'm actually using my CircleCI as part of the tag, for the Docker image that I'm going to push to GCR. I have already provisioned a Kubernetes cluster and set up the deployment and service and all that beforehand. So really all this job is doing is updating a pre-existing service to point to the latest Docker image. And before I pause for questions, I'm going to pause for questions in a moment. I want to give you all kind of a live demo of what this might look like. So I'm going to blow up the font. I'm adding just a simple line of code to this, this bare bones Go web server I hacked together, and I have a version endpoint. So if I ping this this service, it's going to furnish a couple of version related pieces of information in the SHA, and also just I thought this would be kind of quirky. I'm also going to furnish the time in which this binary was compiled, right, for science. So as I'm sure many of you are aware, the default behavior in CircleCI, you can certainly change this with, branch level filters. You can change the webhook behavior on GitHub, but every commit is going to kick off a build. So by committing directly into the master branch, I just kicked off a new build. This is what the full configuration file looks like. We saw the deployment part already, but if all of you are curious, as I'm sure you are, this is where I've got my build logic. This is a really, really simple example, but I'm basically running Go test. I'm calling a makefile target to build a Linux binary, and then in the makefile, in the makefile also handles the logic of porting that into the Docker container. I'm tagging it with the CircleCI, and then I run the deployment job down here. So this will take, I want to say maybe 2 minutes to run. So while this is running, at the end of which in my deploy job, it's going to furnish an IP address. It's going to furnish the address of where the service is. I just want to pause here for questions, comments, thoughts. Full disclosure, I think this page is taking a moment to load just because by virtue of the fact that I have like a million projects building on Circle, Circle projects, personal projects, etc. So I'm just going to give this, actually, I'm just going to refresh this, give this a second. All right, so Jesse Spencer asked, how would you handle separate dev, stage, and prod environments? I'm just going to take a stab at this. You probably would have multiple. Environments pre-configured, right? So you might have a single Kubernetes cluster with multiple deployments. You might have multiple Kubernetes deployments. You might have multiple Kubernetes clusters in separate environments. So leveraging the power of workflows, you're going to have separate job declarations for each of those environments, or realistically, you might have different deployment scripts, and each, depending on the environment that you're trying to deploy to, you just invoke a different script, and you could use conditional logic in your configuration file. You could use different job declarations within the workflow. So there are a number of ways in which you could handle deploying to different environments. But all of that logic, all of that logic will either be encapsulated in your deployment scripts themselves and or the workflows declaration, right? All right, as a student, Edward asked, I'm going to answer this live, as a student who is just trying to experiment with CircleCI and Docker for fun, what is the best way to get started with a limited or no budget to work with? Great question. So I believe that we give everybody with a GitHub account gets at least one free container, right? So there are we have a number of really, really awesome just getting started docs. I think it behooves you to run through a Hello World program, right? Run through a Hello World program on our platform. And we definitely have a number of resources, docs, videos, tutorials that can help you get started. And I think also getting started with our 2.0 platform is a really, really great excuse, if you will, to get started learning how to use Docker. Docker is an immensely powerful technology. You don't have to be an expert by any means to use it on our platform, but I definitely think it's worth taking a look at, right? Awesome. Okay, so this job, I assure everybody this job will be done in a minute, and then at the end of the deploy job, we're going to see an IP address, and that's where we're going to ping the service that we just built. Awesome. Awesome. And then, I assume most of you are pretty familiar with the platform, but all of these steps here on the build page, these are all commands that are specified in our configuration file, right? And if we click and expand on any of these, we can see the output, right? So really what we're doing in the UI is we're really just redirecting the output from standard out to to the UI. And then, I could have, just iterated through a loop, right? And continue to ping the service until it furnished an IP address. I'm just waiting a minute, 2 minutes before I run the queue control command to get the service. And then look, awesome. This is awesome. So success, application IP. Awesome. So we have built it. We tested the Go code first, then we packaged this up into a Docker image, and then we deployed this Docker image in less than 5 minutes to a Kubernetes cluster running on GCP. And actually the piece of code I just committed, let's actually test the functionality that I'm trying to build here. Awesome, awesome. So we have a version endpoint. The version endpoint is going to show the SHA that's associated with this particular binary, and then the build compilation time, right? So it's really that easy. And again, we did this all in less than 5 minutes. We built an application, we tested it, we containerized it, we deployed it in less than 5 minutes. Ooh, okay, I see another couple of questions. Let me just pause here and take a stab at these. Okay, Karen asked, what is the maximum build time, pipeline plus testing for builds? That's a really, really good question. It depends. It depends. I know that you can configure different timeouts within the configuration file itself. I want to say the default time for any given command in the configuration file is 2 hours. I know you can certainly change that. My 2 cents is that if you have a build, right, if you're compiling assets, and granted, you know, all things being equal, if your build is taking more than an hour to 2 hours, I definitely think you should look at test splitting, and I definitely think you should kind of something is going on there if your build is taking an hour to 2 hours, right? And these things happen. We sometimes have monoliths, you know, legacy code, legacy applications, really large monolithic Java applications. I want to say though, your build, test, and deploy process should not take more than 2 hours. But that's just my humble opinion. And I mentioned something called test splitting. This webinar is really about deployments, but I'm just going to pause and talk about test splitting and parallelism. When you run builds, you can run those builds either in a single container in isolation, or you can distribute those across n number of nodes, ultimately configured in your configuration file. And parallelism, in conjunction with something called test splitting, is where you can see some pretty significant performance improvements in your overall build time. And let me just pause for one more question, and then we're going to just go into the ECS deployment. Okay, Jesse, Spencer asked another question. Would you suggest provisioning Kubernetes clusters using CircleCI workflow or deploying to an existing cluster as you have shown? That's a really, really good question. You could totally do both. The only thing, if you're provisioning a brand new cluster using CircleCI, depending on how you've structured your configuration file and or your deployment logic, you would want to check to see, so in your deploy job, you would want to check, you'd want to use some conditional logic and or you'd want to separate your jobs out a little bit to see if there's already a pre-existing Kubernetes cluster before trying to like update the service, but both are totally possible. Okay, and then Karen responded, some data processing tests take a very long time. Totally. You're absolutely right about that. So I'm actually going to defer to Eddie or George, who are also on the webinar, to see if there's an upper bound for how long a single job or a single workflow can take on a platform. Okay, and then let's, so we've got the ECS deployment. I'm just going to dive into the configuration real quick. I've got a slide. Let's see. And then we'll deploy live to ECS. And for those of you, ECS is AWS's proprietary container orchestration service, conceptually identical to Kubernetes. In all fairness, Kubernetes is significantly more robust, but make no mistake, ECS is a really powerful, easy to use tool, and it certainly gets the job done. Okay, very similar, right? We've separated our build, test, and deploy logic into different jobs. I've omitted those in this sample code block. We're really just taking a look at the deploy job declaration. We're going to take a gander at the workflows declaration below, but I just want to pause here. What do we see in this deploy job? We only have a single run command, right? So all of our deployment logic is encapsulated in this deploy script, right? And when I say the deployment logic, we're going to invoke the AWS CLI to update the task definition in ECS to point to the containers that we're building in this workflow. And I think before I conclude, I definitely want to just show everybody what that deploy script looks like. But it's really important to realize that, you know, powerful shell scripts in conjunction with makefiles, you know, in conjunction with other things, rake files even, you put all that together. You can also simplify your configuration file by scripting a lot of the requisite behavior. So again, we've got a build job. Our test job is incumbent on a successful completion of build. Our deploy job is incumbent on a successful completion of test. And again, we're using branch level filtering. We're only going to run the deploy job. We're only going to run the deploy script ultimately on a successful push to the master branch. What would that look like? Well, it just so happens that I have a PR in flight, and this is what our containerized application looks like. It's a simple single-page app. It could be your application, super straightforward. This application itself, though, is comprised of 2 containerized services running in ECS, right? And what we're trying to do here is we're going to do it live, and we're going to change the color of this button from red to green. We're going to do it in real time, and the total time from completion, from building, testing, and deploying, I want to say is going to take 5 minutes, right? So we've got a PR in flight. It's a wafer-thin commit, right? We're just committing a single line of code. The single line of code is going to change both the color and the text field in that button. And we see this red X next to the PR, right? So because CircleCI has beautiful integrations with both GitHub and Bitbucket, right? We see that one of our test job has failed on Circle. When I click details, I'm redirected to a build page on Circle. I see exactly which test failed. So even though we've got the PR that's updating the color, or the PR is updating both the color and the text field in the button, this to me indicates that our tests, we're not testing for the adequate text field on Circle. Right, so now we're armed with this newfound knowledge. We know which test failed. I'm going to update the test. I'm going to change to the update button branch. Totally fine to use GitHub's online text editor. I would say don't do this in a production-like environment, but I think for the purposes of our webinar today, this should suffice. So we're going to commit this change, again, wafer-thin change. We're going to commit this directly into the branch, right? And remember that every commit is going to kick off a build on CircleCI. So if we go back to Circle, and again, I really believe that it's just taking a second to load because, as you can see, I have literally a million projects building on Circle. Actually, let me see. Okay, awesome. This is what the full configuration file looks like for this workflow. This is our build job, our job declaration up here, our test job over here, and then lastly, our deploy job. And again, really important to point out, this deploy job is doing one thing and one thing only. It's running this deployment script, right? And that's where we've encapsulated all of our deployment logic. This should only take a minute to complete because we're only on this workflow, right? Because this workflow is running on the update button branch. We're only running the two jobs, right? Because the deploy job's only going to run on a master branch. So we're going to build the Docker images. We're going to run some tests in the Docker images. Once these tests pass, we're going to see that indicated in GitHub. We're going to merge this into master. It's going to kick off another workflow. The master run of this workflow is going to update the task definition in ECS. It's going to trigger a rolling deployment, and if everything goes well, this button is going to change green. I want to pause here for questions, comments, thoughts. So this right here indicates that, yeah, the builds are currently running on Circle. Once these tests pass, I assume they will, we're going to see a beautiful green check mark, excuse me. Okay, so the test job has been running for 40-something odd seconds. The estimated time to completion is furnished from historical build data. While we're waiting for this, I'm just going to riff about a couple other product features that might be worth pointing out. See here over resources, a really powerful feature on our 2.0 platform that was not at all applicable to CircleCI 1.0 is this thing called configurable resources. What are configurable resources? So configurable resources effectively are mappings to different EC2 instances. So the ability to programmatically define the system resources that are given to an individual build, right? So for some jobs, for some builds, I'm going to call out Android builds here for a second. Android builds historically are very, computationally memory intensive, and oftentimes are medium size, that is to say the regular size builder boxes that we run Android builds on oftentimes run out of memory, right? So for a lot of our customers, they'll get this nefarious exit code 137. That's like the smoking gun. That's a clear indicator that they ran out of RAM. So we do have the ability to specify the resources with which a given job is ran on, or resources with which a given job has, excuse me. Awesome, awesome. So this wonderful green check indicates that our build and our tests have passed on Circle. So we're just going to merge this right into master. And then this is going to kick off another workflow. This workflow is going to be comprised of 3 jobs: build, test, and deploy. The deploy job is going to update the task definition in ECS. Again, pausing for questions, anything at all. Well, this is going to take a couple moments to complete, so I'm just going to move to another slide here real quick. So we do have some limitations, right? And I do have to call, full disclosure, I have to call out some of these current limitations. I think the biggest limitation for deployments on our system is that we don't have a first-class rollback function, right? I'm going to throw out a kind of convoluted term here, but it's really important. Referential transparency is the term in computer science where every time you have a function and that function takes a value, that function is going to return the same value each and every time, right? So in theory, by running a previous commit, whatever that commit was, the last known good commit, the artifact, right, in accordance with referential transparency, the artifact of the last given good commit should be functionally identical to whatever the last known good piece of code was running on either production or dev or staging or whatever. So my advice to folks who are really thinking about rollbacks, and rightfully so, I mean, rollbacks are pretty important, would be to run the previously known commit associated with a green build. And then our build-centric model is optimal for linear deployment pipelines. What does that mean? So we do not have a first-class way to do something like a blue-green deployment, for example. And then another limitation/caveat would be to use handoffs within your build for more complex features like blue-green deploys and things like that. So a tool that I would think about using in conjunction with CircleCI would be like Spinnaker, for example. Those are the limitations that come to mind, but if any of you can think of anything or have any other questions that you'd like, either myself or my colleagues to answer, please don't hesitate to reach out. I do want to check the status of this workflow real quick. Okay, so our test job is running. So this should finish any moment, then our deploy job's going to run. This job is going to take about a minute to run, and then it's probably going to take another minute. It's going to take another minute or so for the task definition in ECS to be updated, so I think this would be a good opportunity to just take a look at the deployment script. So this is our deployment script. It's a simple shell script. It's written in Bash. Bash is awesome. And we've got a couple of functions. We've got three primary functions. This is where we update the task definition, right? This is the function where we register said task definition. And to just disambiguate folks, for those of you who aren't intimately familiar with ECS, a task definition, the best way I could describe it, it's like a deployment in Kubernetes, right? It's effectively a manifest that specifies a couple of containers. It specifies, the port mappings between those different containers, and more importantly, it also specifies the resources with which to allocate to an individual container, right? So we can think of a task definition effectively as a manifest. This is where we create our task definition. This is where we register our task definition, and then where we put it all together is in the deploy function itself. And the deploy function calls the task definition function and also calls the register definition function. So again, this is where we encapsulate the bulk of the logic in our deploy job. In fact, all of our logic is encapsulated here. If you were doing something with Kubernetes, it would be the same thing, right? Is we invoke the AWS CLI, the AWS command line interface in this script. You can see here, a great example where we're calling the ECS command. No doubt, if you were doing something with Kubernetes, you would invoke kube control, right? And the ability to specify, any Docker image under the sun is your primary execution environment. You would probably use an image that has kube control pre-baked in, right? Just to save, time and all that. So my colleague, Eddie Webb, actually called out that we can, in fact, do blue-green deploys. In fact, I've seen him run through a couple of Canary projects that utilize that functionality. I think he uses a tool called Cloud Foundry, and it should be indicated in our doc. So if any of you, Google Cloud Foundry, CircleCI.com, there should be some more information there. Thank you for calling that out, Eddie. And of course, this very much depends on your application architecture, right? Okay, success. Our deploy job has executed successfully. I'm going to give it a moment just because I know it could take a moment for this task definition to update. If it doesn't update, my credibility is totally on the line, but we'll give this a second. Okay, so JP asked, can we show where we call that deploy script? He says he thinks he did it. I did it earlier, but just to call it out again here. In our configuration file itself, in this job declaration, super straightforward job declaration right here. Our single run directive invokes the script and then just passes it a simple parameter. Also, follow up to the question earlier, how would we deploy to multiple environments? Let's just say you had a single shell script that encapsulated all of the logic. We could, here. This is how we could pass different parameters to a script inside of a job. And again, we could use conditional logic inside of our run directives to potentially deploy to different environments. Yay, awesome, awesome. Okay, so we've built it, tested, and deployed an application to ECS in about 7.5 minutes. And I just want to reiterate that it's that easy, right? Of course, all of this depends on your application and your application environment, but it's that easy to build, test, and deploy Docker images. Again, the emphasis on the webinar today was Docker. I want to circle back. You are not by any means forced to use Docker, right? So you could deploy a WAR file to, maybe a Tomcat server. You could deploy a jar file to whatever your environment is. So you're not necessarily, obviously you're not forced to use Docker by any means, but Docker is a pretty good example. But again, whatever build artifact you're producing at the end of a build, at the end of a workflow, with some powerful shell scripting, some conditional logic, and workflows, you can take that artifact, again, whatever that artifact is, and deploy it from point A, being Circle, our build system, into your environment. And notice how I didn't say production. It could be staging, it could be dev, it could be QA. But that's all I've got today. So again, just to recap, we went through what a simple deployment via SSH would look like. We deployed a simple containerized Go application to Google's Kubernetes engine. And then we deployed this thing right here, this simple single-page application to AWS ECS. And we did all of it in under an hour, which is pretty awesome. So again, want to circle back for questions, comments, thoughts, concerns? So Jesse Spencer asked if we can provide the config files used in the demo and the deploy script. I don't see why not. We might have to obfuscate some of the, no, all of the secrets are contained as NVARs, so I'm going to circle back with the team, but I don't see why not. You know, there's some pretty powerful examples, and I think it would definitely be worth sharing with all interested parties. You know, if any of you have any follow-up questions, you know, maybe you want to schedule a demo at some point, you work for a company who's interested in you know, kicking off a trial with CircleCI, you can find me at chris@circleci.com. It's one of the benefits of being, you know, employee 31 or something like that. My hacker name on GitHub is this kind of obscure Latin word, Adafix. It's Latin for builder, but please don't hesitate to reach out at all. Okay, an anonymous viewer asked, 80% of what I'm explaining is going right over my head. Where would a complete noob like me start? Okay, somebody who's new to DevOps, new to the space, relatively new to software. I really think that our Hello World docs do a really, really good job of just getting you building in a relatively short amount of time. Just, you know, spinning up a container, even echoing something like Hello World can be a pretty valuable exercise. So I would definitely recommend checking out the docs. Of course, there's a wealth of information on Google. There's a wealth, or excuse me, on YouTube, and of course, Google by extension. So there's a ton of really, really pertinent information out there for people who are relatively new to the space. And you know, I just want to reiterate for all of you who are really, really interested in some light reading, Martin Fowler's book, Continuous Delivery, is absolutely awesome, right? Martin Fowler, Jez Humboldt laid the groundwork, the conceptual groundwork for a lot of the stuff that we frankly take for granted in the ops space today. I hope that answers your question. Yeah, and you know, one of my colleagues just pointed out, we also have a lot of really, you know, awesome getting started content on YouTube ourselves, right? So some of our product evangelists talking about just, you know, what is continuous integration? How do I get started leveraging the platform? So again, there's a ton of really powerful material out there that'll help you get started in no time. I'm just going to hang around for another minute for you know, questions, thoughts, ideas, and some coffee. Oh, wow. Jesse Spencer, would you be interested in doing a follow-up demo with much more advanced workflow examples, utilize context, blue-green deploys, multiple workflows, and maybe provision a Kubernetes cluster with a separate workflow? Yes, Jesse, absolutely, 100%. Shoot me an email at chris@circleci.com, and we can take this offline. I'd be happy to. All right. All right, I'm going to cut it here in a moment. Yeah, again, Chris at CircleCI.com. Don't hesitate to reach out. And honestly, for any of you newbies on, and I don't mean that in a pejorative sense, but anybody on the call who's relatively new to software, relatively new to the space, please don't hesitate to shoot me an email. I'm happy to provide some materials that I think would be helpful as you get started and whatnot. I'm going to cut it here. I want to thank all of you for your time today. I really appreciate it. I also want to give a shout out to my colleagues who helped with questions, Eddie, Matt, and George. Thank you all. Much appreciated, and talk soon. Bye.